Welcome students, this is the video for Friday 1/17. It's Solving Systems Day 3. We're going to learn how to solve them by graphing and by tables today. When we get to class, we'll focus on graphing and tables in the calculator. But for the video here, since most of us don't have calculators at home, I'm going to show you how to do these things by hand and give you a little bit of insight into the calculator stuff along the way. The beginning of the notes just kind of start out with a system of equations is an algebraic problem where two equations are working together to model a situation. It could be two companies that we're comparing the prices of, or two runners that we're comparing in a race or something like that. A system of equations will have two or more variables, but for us, we usually just have two. The solution to a system of linear equations is the two variables in an ordered pair that satisfy each one. So you're going to get an x and a y for each one. To solve by graphing, you must have them in y equals mx plus b form, which we've spent a lot of time talking about this year. You use the m and the b to graph the two lines, and you find where they intersect. And that's all systems are about, is finding out where the two lines hit each other. Okay. In our first set of problems here, this is our system. Y equals 2x plus 1 and y equals negative x minus 2. It's best to have these slopes as fractions. That way when we go to write them over here, we have mx plus b. Our first m is 2 over 1, and our second m is negative 1 over 1. This is up 2 to the right 1. This is down 1 to the right 1. Our b's are always here on the side. This has a b of 1, which is 0, 1. And this has a b of negative 2, which is 0, negative 2. Alright, so we're going to go over here and graph them one at a time. We'll start with the top one. B is where we begin, so we begin at 0, 1, so we put us a nice dot right there. And we're going to go up 2, 1, 2, to the right 1, up 2, to the right 1. And I like to carry this out all the way across the graph. If you don't, it's really hard to tell where they intersect, and that's one of the reasons why we end up using our graphing calculator, because this takes a while because we have to find every point. I'm going to go back the way we came, so down 2, over 1, down 2, over 1, down 2, over 1, and this is my graph. Okay. I'm going to switch colors and do the second one. The second one crosses at 0, negative 2, which is right here. And for this one, we're going to go down 1, over 1, down 1, over 1, down 1, over 1. And the opposite direction, you would go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And we would draw our line. And we can see that our two lines hit right there at that point, which is left 1, down 2, which is negative 1, 1. I said down 2, but it's just left 1, down 1. And this is our solution. The checking part we're going to learn about later on in the video, so we'll leave that blank for now. Alright, the next one, I want to get an mx plus b form, so I'm going to put a 1 in front of there, and since this has nothing on the end of it, it's 1x plus nothing, and I like to have my m's as fractions, so I'm going to put 1's under those. So the first one has a slope of 1 over 1, and the second one has a slope of negative 3 over 1. This is up 1, right 1. This is down 3, right 1. This has a b of 0, which means our 0, 0 is our y-intercept. And this has a b of 4, which means our y-intercept is 0, 4. And let's go ahead and graph these. This first one starts at 0, and it goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And in the opposite direction, it goes down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And that is our line. This is also known as the parent function, if you remember that from earlier in the year. Our next one starts at 0, 4, which is up 1, 2, 3, 4. And it has a slope of down 3, 1, 2, 3, over 1, down 1, 2, 3, over 1, down 1, 2, 3, over 1. And there's no reason to go backwards because it goes off of the graph. And this is our second line. We can see that they hit right there, which is to the right 1, up 1, or 1, comma 1. And this is our solution. So it's as easy as that. And it's going to get a little bit easier in class once we show you how to do it on the calculator. And the next thing shows us how to do this using the table. It's the point where the two lines intersect each other. So what it means is that they're going to have the same x and the same y during that time. Okay? So we're going to search the table for where they have the same x and the same y. So at 0, -1, this one has 0, 1, so I know that that is not the intersection. At 1, it's supposed to go with 1. That is not the intersection. At 2, it's supposed to go with 3, and at 2, it's supposed to go with 3. And you can see that this is the spot where they are the same. 3, 5 go together, and 3, 4 go together. We're not sure about -1, and we're not sure about 4, 7. But we do know at this point that they both hit at 2, 3. And lines can only hit in one spot. So we're done on that part. Okay? The intersection could happen off of the screen. So if you were doing this with your calculator, you might need to scroll up or down to find the two intersections. It may not be as easy as where we can see it on our screen like this. All right, this table is blank, so I'm going to use my graphing calculator. I type this in to y equals, and I hit second graph, and so I bring up my table, and it shows me that this is -4, -3, -2, -1, and 0. And this one I do the same thing. I type this into y equals, and hit second graph, and I get 4, 1, -2, -5, and -8. And I'm going to go through the same process I did just a second ago. 0 goes with -4, not 4. 1 goes with -3, not 1. 2 and -2 go together. Those don't, and those don't. So our answer is 2, -2. This is the only spot in there where they're the same. So these must hit at 2, -2. All right. If you're given a graph, this is one of the easiest things to do, is to find their intersection. All you've got to do is take a look at the graph, and you're just looking for where do the two lines hit each other. These hit each other at over 1, up 2. So the solution is 1, 2, and that's an ordered pair. These lines never hit each other. They're parallel, and so that means that these have no solutions, because they don't hit each other. These two lines here are like this red line and this blue line. They're directly on top of each other, and so what that means is that they hit each other everywhere along the line, and that's said to be infinite solutions. It just means they always touch, they always hit each other. Okay? Every x that works for the blue line and y also works for the red line. A system of linear equations has no solution when they are parallel, and a system of linear equation has infinitely many solutions when they are the same line. To check the solution of a system of equations, to verify that it works in both of them, it's just a series. You just plug it in. This is your x value, this is your y value, this 1's going to be put over here, the 2 is going to be put over there, and if it makes a true statement, it checks. If it makes a false statement, it does not check. So I'm going to put the 2 over here where y is, I'm going to put the 1 here where x is, and I'm going to keep everything else. So 2 equals 1 plus 1 is 2. This is a true statement, so that means it works for that one. We're going to do the same thing over here, 1 comma 2. This is our x, that's our y. So the x goes there, the y goes over there. So this is 2 equals -2 parentheses 1 plus 4. I distribute here, that's 2 equals -2 plus 4. 2 equals -2 plus 4 is 2. This is also a true statement, so this checks, meaning that 1, 2 is the solution for this system of equations. All right, so this last method here, this is what we're going to do in the calculator, and I've done some screenshots over here on the right to show you what it looks like in the calculator. We're going to kind of teach you a new method to get them into the calculator. We've been boxing our y, subtracting our x over, and dividing everything, and some people have that down, and you can continue to do that, but we're going to show you a new method today, and these are the 4 steps. Step 1 is to do a left-handed parenthesis. Step 2 is to do a right-handed parenthesis. Oops, I messed that one up. Step 1 is to do a left-handed parenthesis. Step 2 is to do the opposite of x. Step 3 is a right-handed parenthesis, and step 4 is to divide by the y number. Okay, and so what that looks like is we put a 1 in front of everything here, and I'll do in red everything that we're going to do. Step 1, left-handed parenthesis. Step 2, the opposite of x. We have a 1x, so we do the opposite of that, which is minus 1x. Step 3 is a right-handed parenthesis. Step 4 is to divide by our y number, which is 1. This is ready for the calculator, and you can see I already put it right there in y1. In the second one, we do a left-handed parenthesis for step 1. The opposite of 3x is minus 3x. Right-handed parenthesis, and we divide by, that's a negative 2, and this is ready for the calculator and goes right there. Once we get them into y equals on the calculator, we push graph, and that's what we're looking at. Do they hit each other? These hit each other right there, and that's going to be our answer. We can actually get our calculator to tell us that answer by hitting second trace, and we want to know the intersection. Number 5, we'll go through it hitting enter a few times, and we can see that the answer pops up on our screen right here. These hit each other at 2, negative 3. So the answer to that system of equations is 2, negative 3. And this is what we're going to spend time in class working on Friday, is making sure you guys know how to do this in the calculator. All right, the next one we're going to use the same set of parentheses, everything. We want to make sure that we get 1s in front of these. Left-handed parenthesis, opposite of 2x, right-handed parentheses, divide by 1. That's ready for the calculator, and we put that right there in y1. Left-handed parenthesis, opposite of 3x, right-handed parenthesis, divide by negative 1. That goes right there. We push graph. This pops up. We push second trace. We're looking for an intersection, so we do number 5, and it spits out our answer right there, 1, negative 1, and that is the answer to that system of equations. Okay. This method, you can see right here, the amount of work required to do this is much less than the substitution and elimination and hand graphing that we've learned before. This is by far the easiest, fastest way to get the system of equation, but it does require the use of a calculator. And if you don't have a calculator in your possession, then you have to revert back to one of the other ways. Luckily for the EOC, you're going to have your calculator, and so this will be the best way to do your systems of equations.